Today we'll look at solving systems by elimination, sometimes called the combination method. Step 1. Align the terms of both equations. You want x on top of x, y on top of y, and numbers on top of numbers. Step 2. Add the equations after eliminating one of the variables using opposites and solve for the other variable. Step 3. Substitute the variable from step 2 into one of the original equations to solve for the other variable. And finally, step 4, write the answers as an ordered pair to show the point of intersection. Let's look at some examples. X minus 2y equals negative 19, and 5x plus 2y equals 1. So we see that we have our x's, y's, equal sign, and numbers lined up. So we're ready to add the two equations together. So you can put a plus sign and be ready to add. Well, negative 2y and positive 2y cancel out, making 0. X plus 5x is 6x, and negative 19 plus 1 equals negative 18. Divide by 6 on both sides, and we find that x equals negative 3. Now we can plug in negative 3, or substitute it into one of the original equations, and I chose the first one. Negative 3 minus 2y equals negative 19. Add 3 to both sides. Negative 2y equals negative 16. Divide by negative 2 on both sides, and you get positive 8. Your final solution is negative 3, 8. Let's look at another example. 3x plus 4y equals 18, and negative 2x plus 4y equals 8. Well, we're not quite ready to add these equations yet because 4y and 4y won't cancel out. But if I made this negative 4y, then negative 4y and positive 4y could cancel out. So I'm going to multiply the entire top equation by negative 1. So that would result in negative 3x minus 4y equals negative 18. Now I can add the two equations. My negative 4y and positive 4y cancel out. Negative 3x plus negative 2x is negative 5x, and negative 18 plus 8 is negative 10. If I divide by negative 5 on both sides, I find that x is 2. I can substitute 2 back into one of the original equations, and I chose the top one. So I get 6 plus 4y equals 18. If I subtract 6 on both sides, I get 4y equals 12, giving me y equals 3. My final solution is 2, 3. Let's try one more. 2x plus y equals 3, and negative x plus 3y equals negative 12. Well, I do have my x's and y's and numbers lined up, but right now I don't have terms that'll cancel each other out. I'm going to multiply my top equation by negative 3 so that negative 3y and positive 3y could cancel out. There are other options you can choose, but that's the one that I chose. So if I multiply the entire top equation by negative 3, I get negative 6x minus 3y equals negative 9. Now I can add up my two equations. My negative 3 and positive 3y will cancel out. Then I could add the rest of it, and I get negative 7x equals negative 21. Divide by negative 7 on both sides, and I find that x equals 3. You can go back to one of your original equations. Again, I chose the top one. 2 times 3 plus y equals 3. 6 plus y equals 3, and I get y equals negative 3. My solution is 3, negative 3. And finally, one last example. This one has a little more work involved. 7x minus 12y equals negative 22, and 5x minus 8y equals negative 14. So again, there's nothing to rearrange. I have x's, y's, equal signs, and numbers lined up, but nowhere do I have opposites. So one way to do this is to try to find the least common multiple that can cancel out. So I look at 7 and 5. Well, both of these numbers are divisible by 35, so if I can make one negative and one positive, that could really help me. So I'm going to multiply my top equation by negative 5. That'll give me negative 35x. And I'll multiply my bottom equation by positive 7, which will give me positive 35x. But whatever I do to one part of my equation, I have to keep balanced all across. So if I multiply the entire top equation by negative 5, I get negative 35x plus 60x equals positive 110. On the bottom, if I multiply my entire second equation by 7, I get 35x minus 56y equals negative 98. Now I'm ready to cancel out. Negative 35x plus positive 35x cancels out. Positive 60 plus negative 56 gives me 4y, and 110 plus negative 98 gives me positive 12. If I divide by 4 on both sides, I find that y equals 3. I'm going to substitute 3 for y in one of my original equations, and again I chose the top one, but you can choose either. 7x minus 12 times 3 equals negative 22. Just be careful that you're substituting in for the correct variable. 7x minus 36 equals negative 22. I'll add 36 to both sides, giving me 7x equals 14, and finally I find that x is 2. So my final solution is 2, 3. You should always substitute your point back into both equations of the system to make sure that they work.